For centuries, people have been tracking seasonal lake ice patterns for a variety of reasons. To many communities, lake ice signals opportunity. It enables ice fishing, winter recreation, even access to remote locations. Take transportation in northern Canada, for instance. The Tilicha Winter Road provides an ice bridge atop which supplies can be hauled to remote Indigenous communities of the Northwest Territories. It is the only ground route and is open for just a few months of the year while the lake ice is present. But these communities now face a serious threat. As climate change shortens the duration of the ice season, there is less opportunity to receive sufficient supplies to last through the year. Because seasonal lake ice patterns are important to so many communities, especially those indigenous to these regions, ice records have been collected for centuries. Records even date back to Shinto priests who lived by Lake Suwa in Japan around the 15th century, who believed that large cracks in the ice were created by their god. Today, this information can be used to tell us how climate change has altered the conditions necessary for ice on such lakes to exist. A recent study surveyed seasonal changes of lake ice freeze-up and breakup associated with the difference in air temperature, precipitation, and climate oscillations by examining lake ice records for 152 lakes in the Northern Hemisphere from 1951 to 2014. Using records from the Global Lake and River Ice Phenology Database at the National Snow and Ice Data Center, Dr. Liana S. Lopez and co-authors from New York University found trends suggesting broad changes in seasonal lake ice patterns across the Northern Hemisphere. Using statistical analysis, Lopez found that 97% of lakes in the study exhibited ice breakup earlier in the spring season, averaging about 1 day earlier per decade between 1951 and 2014. The trend varied between lakes of different location and depth, but the primary driver for earlier ice breakup was spring air temperature. Warmer temperatures, earlier ice breakup. However, abrupt changes in spring ice breakup were often explained by sudden climate shifts, such as phase transitions of climate oscillations. Climate oscillations are cyclical changes to regional or global climates that cause fluctuations in temperatures, precipitation, and weather patterns of different regions on interannual and multi-decadal timescales. Some examples include El Niño, the Pacific Decadal Oscillation, and the North Atlantic Oscillation. For example, 1998 and 1999 were the most common years for early ice breakup among all of the lakes, 2 years following climate oscillations switching to their negative phases associated with the warmer weather in the Great Lakes. Similarly, a climate oscillation phase switch in the 1980s associated with warmer air temperatures in Northern Europe likely brought on abrupt early ice breakup in Sweden and Finland during that time. In addition to climate oscillations, the lake altitude and depth determine the vulnerability of certain lakes to early ice breakup. Low-lying, deep lakes were most susceptible to changes, while high-altitude, shallow lakes were less so. The study by Lopez was one of the first to identify the trends, drivers, and abrupt shifts in the lake ice breakup in the Northern Hemisphere. Using over 60 years of data, the researchers were able to link changes in seasonal lake ice patterns to warming temperatures and climate patterns over many decades. While some lakes saw only modest changes, the impending pervasiveness of warming is undeniable. We are headed towards a new normal in which intermittent lake ice and thus unstable living conditions for the wildlife and people in these regions will become unavoidable. The window of opportunity is closing for communities around the world that depend on lake ice. With adjustments already being made for voyages along the Chilcho Winter Road, the people of the Northwest Territories are some of the first who are threatened by the disappearing lake ice caused by climate change. This post was originally made on September 2, 2019 by Naila Hussein. It was titled, "Tracking the Transience of Lake Ice in a Changing Climate," and featured a paper by Lopez et al. 2019 titled, "Reaching a Breaking Point: How is Climate Change Influencing the Timing of Ice Breakup Across the Northern Hemisphere?" This has been Oceanbites Out Loud. Check out oceanbites.org for this post and other neat posts. Thanks for listening!